Hey guys, this is going to be notes on lesson 4-1 over congruent figures. Now, when we deal with congruent figures, when we deal with figures that look somewhat similar, like these two right here, you're going to have to understand that all the angles need to be congruent and all the sides need to be congruent so that we can say that two figures are congruent. Now, starting out with this particular set of notes, the directions say each pair of polygons is congruent. So that means that this triangle is congruent to this triangle. Find the measures of the numbered angles. Now what you have to do is you basically have to compare the two triangles to find out what angle 1 is and what angle 2 are. Here in the second triangle, we'll number them. This is the first triangle and this is the second triangle. The first triangle has an angle of 1. And if you look at the other triangle, since we know that they are congruent, this angle is a 90-degree angle. It's a right angle. So what can we say about the measure of angle number 1? Well, since they are congruent, the measure of angle 1 is equal to 90 degrees. Remember, all the angles need to be congruent and all the sides need to be congruent so that we can say that the two figures are congruent. Well, we already know that the two figures are congruent, so the measure of angle 1 is corresponding to this angle. They are the same angle, so the measure of angle 1 has to equal to 90 degrees. Now, since this is the angle for angle number 1, and to the right of the 90-degree angle, we have 40 degrees, we're going to say that the measure of angle 2 is equal to 40 degrees. Okay, for those advanced kids, can you tell me, now that we know that the measure of angle 1 and the measure of angle 2, the measure of angle 1 is 90 and the measure of angle 2 is 40 degrees, what would the measure of angle 3, now where is 3? Well, we're going to put it right there. What is the measure of angle 3 if this is 40, this is 40 and this is 90? Well, some of you guessed correctly. What we had to do was take 180 degrees and add those two up. 90 plus 40 is 130 and subtract it from 180 degrees because the interior angle is, the sum of the interior angles is 180 degrees. So if you take 180 and you subtract 130, you're going to end up with 50 degrees. So this right here would be 50 degrees, just like that. For the next example, we are going to look at two figures that aren't necessarily triangles. You'll notice that this is a quadrilateral and so is this one. But it says in the directions here, each pair of polygons is congruent. Find the measure of the numbered angles. All the angles need to be congruent and all the sides need to be congruent so that we can say that the two figures are congruent. Well, we already know that they are congruent to each other. This figure, we'll call this one figure number 1, is congruent to figure number 2. Basically, this means that all the sides are congruent to each other and all the angles are congruent to each other. So this angle is congruent to this angle. Angle number 1 is congruent to that angle. Angle number 2 is congruent to this angle. Okay? And angle D is congruent to angle I. And what you can do, this is what I like doing when I'm figuring out, since we know that the polygons are congruent here, we should make a list. So the measure of angle A corresponds to the measure of angle F. So that means the measure of angle A is equal to the measure of angle F. Okay? So we're making a list of all the angles that are congruent. So the measure of angle B will be equal to the measure of angle G. The measure of angle C will be equal to the measure of angle H. And the measure of angle D, it's kind of strange to see it, right? Here, these two are congruent to each other, and that will be equal to the measure of angle I. Okay, so now that we have what each angle's correlation is, or correlating angle, corresponding angle, we can go to angle B, and that's going to be equal to angle G. So the measure of angle number 1 is going to be equal to the measure of angle G, which is 95 degrees. And the measure of angle 2, well, what's 2? Which is angle C, and that's going to be equal to angle H, which is 60 degrees. So the measure of angle 2 is equal to 60 degrees. Now we can go ahead and try and figure out what, now we can go ahead and say that the measure of angle A, or whatever this number would be, is equal to 45 degrees, and angle D would be 150 degrees, but that's not what they're asking us for. They're specifically asking for angle number 1 and angle number 2, which is angle B and also angle C. So this would be our answer for a problem like this. Okay, for exercises 3 and 4, can you conclude that the figures are congruent? And we're supposed to be able to justify our answers. Now, what you just heard about congruent figures is you have to have all angles congruent and all sides congruent if you're going to say that the two figures are congruent. In problem 3, it says that triangle SRT is going to be compared to triangle PRQ. Are these two congruent to each other? Well, you need to have all of the sides congruent and all of the angles congruent. So we're going to look at this figure to see if we have all angles and all sides equal to each other, so we can say that these two would be congruent. And if they are congruent, you're going to say this: triangle SRT is congruent to triangle PRQ. And we haven't figured this out yet. We're questioning it just to see if they are congruent to each other. So we have to look at the figure, okay? And we have to compare and see if all the sides are congruent to each other and all the angles are congruent to each other. Now you will notice right away that SR and PR are being compared to each other. These two right here are sides that are away from the 90-degree angle. In fact, the 90-degree angle faces them. You see that? So SR is a side that should be compared to PR. And we don't know anything about this side. We have no clue as to what's going on with this side. All we know is that this is a 90-degree angle and this is a 90-degree angle. So that means that the measure of angle T is congruent to or equal to the measure of angle Q. You know something else we know because of vertical angles? That the measure of angle SRT, the measure of angle SRT is also equal to the measure of angle PRQ. Notice the direction that I went with as I called out the angle. It says SRT is congruent to or equal to PRQ. Okay, so I go from the angle from P going to this vertex right here, and I go to Q, and I want to say that this angle is congruent to this angle because of vertical angles. So the measure of angle SRT is congruent to PRQ, the measure of angle PRQ. And a while back we talked about triangles, and you know the sum of the interior of triangles is equal to 180 degrees. Well, if that angle is congruent to that angle and the 90-degree angles are equal to each other, by default, automatically we can say that the measure of angle S will be equal to the measure of angle P automatically, because since this is 90 degrees and these two are equal to each other, whatever that angle is, we're going to add 90 plus this angle and subtract it from 180, and we're going to end up getting this one. So all three of these angles are congruent to each other by this diagram. This is a very famous picture of two triangles. This one is the first triangle, and this one will be the second triangle. But basically, all the angles are congruent to each other. What you don't know about this figure is the sides. You have no clue about TR and QR. You don't have any idea about PR and SR. And the other one is QP and TS. We don't know those distances or if they're even congruent to each other. So what we have to say, because we have lack of information, is the fact that these two are not congruent. So what would you say to justify your answer? Since we don't know about the lengths of the sides in the figures, comma, we cannot say that the figures are congruent. Does that make sense? We know that the angles are congruent to each other, but we don't know anything about the sides. So we cannot say that they are congruent to each other. The two triangles are not congruent to each other because we don't know anything about the sides. So let's look at the next set of triangles. Okay? This is number 4. Triangle ABC is being compared to triangle FGH. So we're going to call this one triangle number 1, and we'll call this one triangle number 2. I always like numbering stuff to make sure that when I say it as a teacher, you're going to understand which triangle I'm talking about. Well, this one's triangle number 1, this one's triangle number 2, and we're going to compare them. And if you notice right away, we have some sides that are being equal to each other. They tell us through the tick marks which side is congruent to which. Okay? HF, H has a double arc, and it goes to F, which doesn't have any arc, right? So HF, which is segment HF, is congruent to which one? Well, look at the tick mark. That's a single tick mark. This is a single tick mark. And it goes from a double arc to no arc. So the double arc over here is C, and it goes to A. So it's going to be C to A. Remember, it's got to be in the same order when you're comparing sides and you're comparing angles. So it's HF is congruent to CA. HF is congruent to CA because of the single tick mark. Okay? Now, what else do we know? Well, look at the double tick marks. HG, that segment is congruent to, all right, so let's look at the double tick marks over here. CB. All right, so now we know that two sides are congruent to each other. Let's see if the third side is congruent to each other in both triangles. So we're going to go from G, which is a single arc, to F. So GF should be congruent to, okay, single arc, angle G is congruent, single angle goes to F, and so single arc B has to go to A, so BA. So these three sides are congruent to each other, so that's actually very good if we're going to prove that the two triangles are congruent. Now we got to look at the angles, okay? Double tick mark, triple tick mark. Double tick mark, triple tick mark. Single arc. Are they the same? Yes. So the measure of angle B is in the right spot so that the measure of angle B is equal to the measure of angle G. Because remember, since there are 6 angles and 6 sides, there has to be 6 things that are congruent to each other in order for us to call these two triangles congruent. Okay? So the measure of angle B is equal to the measure of angle G. So that's a good thing. Yes. All right? So the next thing we got to look at is the double arc. Now the double arc is H. So the measure of angle H should be equal to the measure of angle C. And is it, look at that, It's between the single tick mark and the double tick mark, single tick mark, double tick mark, H and C. Absolutely. So we got 5 things that are congruent to each other, which is an excellent thing. Now, since we know that this angle is congruent to this one, B is congruent to G, and H is congruent to C, we can automatically say that the third angle, which is the measure of angle F, has to equal to the measure of angle A. And you'll notice that I like going from the second triangle to the first triangle, and it really doesn't matter even if I switch it, these angles will be congruent to each other. So do we have 6 things congruent to each other as far as angles go and sides? Yes, we do. And remember the rule. All the sides need to be congruent and all the angles need to be congruent in order for us to be able to call 2 figures congruent to each other. And in this example, example number 4, we can say that the triangle ABC is congruent to triangle FGH. And what's our justification? All angles and all sides are congruent, so these 2 figures are congruent. What I'd like for you to do now is go to page 148 and look at more examples on congruent figures.